Assalamu alaikum. Now we will discuss about nuclear physics. What is the nuclear physics and its history and experiment? We have an outline in which we will discuss nuclear physics, study of nucleus, proton and neutron, example of nuclei, type of nuclei, nuclear mass defect, nuclear size and features of nuclear force. First, nuclear physics. What is the nuclear physics? Nuclear physics study of the proton and neutron and center of an atom. They are divided in two types: theoretical nuclear physics and experimental nuclear physics. First, theoretical nuclear physics. Theoretical nuclear physics is the development of model for describing the nucleus and the process that occur within it. In nuclear physics, we will get the nuclear property within the nuclear properties, stable nuclei, binding energy and nuclear mass, spin, nuclear size and nuclear movement. For example, electrical and magnetic nuclear movement. A nuclear model refers to a theoretical framework used to describe the structure and behavior of atomic nuclei. And the experimental nuclear physics. Experimental nuclear physics that particle investigation of the process that occur at the heart of an atom. This including building a better fundamental understanding of fission and fusion reaction and sustained energy generations. And accelerator are devices that speed up the particles that make up of all matter in the universe and collide them together or into a target. And what is the detector? A detector is an instrument which is used to discover that something is present somewhere or the measure how much some there is. A metal detector. For example, fire alarm and smoke detector are the example of detector. And definition of nuclear physics. Nuclear physics is the study of the proton and neutron and the center of atom and the interactions, or the branch of physics deal with the structure of atomic nuclei and the radiation from unstable nuclei. Rutherford Goldfield experiment. In 1911, Rutherford experiment in Goldfield experiment. The experiment involved firing alpha particle at a thin sheet of gold foil that was surrounded by a screen to detect where the particle ended up. Most of the alpha particle passed straight through the fire, but some were deflected at large angle and a few even bounced backward. The result led Rutherford to conclude that atoms are mostly empty space and have a small positively charged nucleus at the center. The Rutherford model proposed that the nucleus contained the majority of the atom mass and positive charge, while the electron and distributed around the nucleus. Gold was used because it could be rolled out very thin without cracking. Alpha particle are type of natural radioactive particle or positively charged particle with the mass without 4 times that of a hydrogen atom. Then study of nucleus. What is the study of nucleus? The center of every atom is called nucleus. A nucleus consists of nucleon, which comprise of proton and neutron. And what is the proton and neutron? First, proton. Proton is a subatomic particle inside a nucleus, have positive charge of magnitude 1.6 10 ki bar minus 19 coulomb. The mass of proton is 1.673 10 ki bar minus 27 kg. The spin of proton is half particle composed of two up quark and one down quark. The rest mass energy of proton is 938 MeV. And then neutron. Neutron is a subatomic particle inside the nucleus having no charge. The mass of neutron 1.675 × 10⁻⁻27 kg. The neutron is half spin particle composed of one up quark and two down quark. And the proton is two up quark and one down quark, and neutron one up quark and two down quark. The rest energy mass of neutron is 939.5 MeV. And then representation of nucleus. Symbol of nucleus, whose chemically symbol is X. X. Upper side of A is atomic mass and Z is atomic number. Atomic mass number A is equal to Z plus N. Z, A is the atomic mass, Z is the atomic number, and N is the number of neutron. And atomic mass is equal to the number of proton plus number of neutron. I determine the mass of the nucleus. For example, hydrogen. Hydrogen atomic number is 1 and atomic mass is 1 and is written as H11. Example of nuclei isotope. For example, hydrogen is 3 isotope, hydrogen 1 proton and 0 neutron. And deuterium 2 and 1 proton and 1 neutron, or tritium H31 1 proton and 2 neutron. Carbon isotope, carbon 6 proton and 6 neutron, and carbon 6 proton and 7 neutron, and carbon 14 is 6 proton and 8 neutrons. And type of nuclei. There are two types of nuclei, even atomic nuclei and old atomic nuclei. Firstly, even atomic nuclei. The nucleus is called even atomic nuclei, which has even mass number, and old atomic nuclei is which has the old mass number. For example, carbon 12, magnesium 24 and silicon 28. They are further classified as even nuclei and old nuclei. Even nuclei, the atomic nuclei in which atomic number is even and neutron are called even nuclei. For example, carbon. Carbon has atomic number is even and neutron is even. And helium. Helium is atomic number is even 2 and atomic mass is 4 even. Both are even. They are called even nuclei. And all nuclei are even atomic nuclei in which Z is old and N is old are called old nuclei. For example, lithium 36. Lithium atomic number is old 3 and atomic mass is even 6. There is called old nuclei. And then nuclear mass. Our nucleus consists of Z proton and N neutron. Let the mass of nucleus be M equal to Z and N. If our nucleus is assumed to be a simple correction of Z proton and N neutron, the mass of nucleus would be just the sum of these constituent nucleus. For example, M is the nuclear mass is equal to Z proton mass plus A minus Z Mn, and M electron mass number, where MP and Mn, small mp and small mn, respectively the mass of proton and mass of neutron. However, a nucleus is not a simple collection of proton and neutron, but they are strongly combined with each other. Therefore, a strong interaction name and the nuclear force. Then nuclear mass. For example, carbon 6 atomic number and 12 is the atomic mass. Number of proton 6 and number of neutron 6. Atomic mass equal to the number of proton plus number of neutron. 6 number of proton plus 6 number of neutron. Then add up. Then atomic mass of carbon equal to 12. And mass defect. What is the mass defect? The mass of the particular atom is always slightly less than the sum of mass of individually proton and neutron, and electron of which is the atom consists. This difference of mass of nucleons in the nucleus and mass of the nucleus measured experimentally is called mass defect. Mass defect is mass of individual neutron and proton is less than the overall that there are measured experimentally is called the mass defect. And then energy and mass relation. Energy and mass relations related as E is equal to mc square. M equal to 1 multiply c square. 1u equal to the 1.6606 multiply 10 power minus 27, and c speed of light equal to 3 multiply 10 power 8 का square. Then E is equal to 1.66 ضرب 10 power minus 27 multiply 3 multiply 10 power 8 का square divided into 1.6606 ضرب 10 power minus 19 MeV. Then energy and mass relation equal to the 931.5 MeV. And then nucleate size. What is the nucleate size? The nucleus is the center of atom. It is made of nucleons, proton and neutrons called the nucleons, and is surrounded by the electron cloud. The size or diameter of the nucleus is between 1.6 fm. For a proton is light hydrogen is about 15 fm. For the heaviest atoms are uranium. Hydrogen, the nuclear size 1.6, and uranium, the nuclear size 15 fm. These sizes are much smaller than the size of atom itself by a factor of about 23,000 uranium to about 1,45,000 hydrogen. Although it is only a very small part of atom, the nucleus has most of the mass. And then nuclear force. Nuclear force is known as nuclear interaction or strong force, are the forces that act between two or more molecules, that is called nuclear force. Features of nuclear force. Nuclear force are primarily attractive. Nuclear force are non-electric. Nuclear force are non-gravitational. Nuclear force are extremely strong, and nuclear force are extremely short range forces, and nuclear force are change independent, and nuclear force are spin independent, and nuclear force have the property of situation. Thank you.